左手右手，隻手擺喺心口，深度5cm 嘅深度，速度1秒2下嘅速度。
Hi, we are Group 9, and we are going to present to you a bioproduct called Urokinase. Our team members include Jason, Mark, and Kyle. Regarding the most common disease worldwide, you may immediately think of cardiovascular disease, or CVD. Around 80 million people are killed by CVD per year, and one of the main causes of CVD is thrombosis, which is the formation of lethal blood clots in blood vessels that block the blood flow. There are three main causes of thrombosis. Normally, a blood clot will be formed due to damages to blood vessels. When you are injured, platelets and fibrin will be sent to the wounds to prevent excessive bleeding. However, abnormal blood clots will be lethal to our body. Unhealthy lifestyle can cause the formation of abnormal blood clots. Obesity and smoking can induce unwanted blood clots to stick together, narrowing the blood vessels. Also, dehydration will thicken the blood, increasing the risk of thrombosis. Lastly, gene mutation due to aging can also cause thrombosis. Believe it or not, a chemical existing in your urine can actually save you from thrombosis. This chemical is called urokinase. Urokinase is an enzyme presented in the blood and urine. It can catalyze plasminogen in the plasmin, and plasmin, another enzyme, can degrade and remove blood clots to restore normal blood flow. After learning the usage of urokinase, let's jump to the section on how to produce urokinase industrially. Here is some background information on cell physiology. Urokinase is generated from the 10th chromosome inside the human liver cells. As mentioned before, since urokinase is secreted in urine, the first obvious method for the synthesis of urokinase is a direct extraction from the urine. Specifically, it is extracted from fresh human urine and is purified by column chromatography. However, it is a bad idea for several reasons. Firstly, the urine might easily get contaminated by pathogens. Secondly, this method gives a low yield of urokinase. Also, multiple steps of extractions will certainly increase the manufacturing costs. In reality, most companies will prefer using biofermentation rather than direct extraction from the urine. So, let me introduce you to the upstream production process. Here is the overview of the production of urokinase using recombinant technology. The 10th chromosome, which is responsible for producing urokinase, will be extracted from the human cells. It is then ligated with the bacterial plasmid. After successful ligation, the plasmid will be transformed to certain cells for mass production. There are several types of cell lines that can be used in production. These include the Chinese hamster ovary cells, modified human liver cells, and E. coli or yeast cells. However, the most commonly used ones are the Chinese hamster ovary cells. This is because it is easy to genetically manipulate Chinese hamster ovary cells that can lead to high productivity. Also, urokinase produced from that is biocompatible to human beings, reducing the risk of immunotoxicity. Since urokinase is typically produced using adherent cell types, microcarriers are required to provide anchors for cell growth. Besides, spin filters are usually used to retain the cells and microcarriers while removing the spent medium. In this way, we can have better control on the reactor environment, resulting in higher productivity. Here are the diagrams for the spin filter and the microcarrier. The spin filter allows the separation of large molecules like the protein and the serum, and the microcarrier allows the cells to adsorb onto its adhesive surface for cell growth. By attaining a well-optimized culture conditions and selecting a suitable management system such as GMP and ISO, the operation can be optimized to produce a high yield of urokinase. After introducing the production process of urokinase, let's move on to the downstream processing. To purify urokinase, a capture column is needed to trap the product from the cell culture broth, and the remaining culture medium can be recycled back to the bioreactor. The column that is used is called copper-2 IDA PAM cryogel column. There are two good reasons for using it. Firstly, it is found that the copper-2 IDA has a good affinity to the histidine in urokinase, favoring its absorption. Secondly, although the detached cells from the effluent might block the transitional column, it has zero effects on the cryogel column. After capturing the product, the column is washed with an equilibration buffer called HEPES to remove the culture medium and loosely bound unrelated proteins. After that, urokinase will be recovered by using an imidazole buffer. To clean the cryogel column, an EDTA buffer is used to remove the remaining copper. Then it is washed with sodium chloride and water. Finally, the column will be reloaded with copper, sterilized and equilibrated before using it. To achieve a high purity of urokinase, more advanced separation techniques such as HPLC-MS and STS-PAGE can be used to remove unwanted molecules. Moving to the formulation section, certain excipients such as serum albumin and sodium phosphate monobasic dihydrate can be used to increase the stability and biocompatibility of urokinase in the blood vessels. In the end, the mixture is freeze-dried in powder form. Considering the packaging, in order to lower the risk of contamination, urokinase has to be packaged into an aseptic container in a sterile area. Then, it's ready to be sold. Using the mentioned upstream and downstream processing of urokinase, around 7 micrograms of urokinase can be produced per day. Due to changes in modern lifestyle, more and more people are getting CVD worldwide. This leads to the need to develop better cardiovascular drugs, resulting in an increase in investment in R&D. Moreover, living in the era with information explosion, we become more aware of how to keep ourselves healthy. These three factors contribute to the increase in the global market size of cardiovascular drugs, and it is expected to grow to around $64 million by 2026. Among all the cardiovascular drugs, anticoagulant drugs, including urokinase, accounts for the largest proportion of the market share, and is predicted to have the highest market growth rate among all. So, improvement in the production process of urokinase is needed to enable mass production in order to meet the upcoming demand for cardiovascular drugs. Also, the drug made should be affordable and accessible so that more people around the world can benefit from it. This can only be achieved by the mutual efforts made by researchers and investors. This is the end of our presentation. Thank you for listening. Feel free to contact us if you have any inquiries.